Yeah, so if we're reading question 8.03, right, they ask how many carbon-oxygen bonds would you need to have in CO2? And so I think this is a little bit confusing in how they word the question because you might be inclined to answer just for one carbon-oxygen, but we have two separate carbon-oxygens, right? So carbon is group 4 in the periodic table. It's going to have 4 valence electrons assigned to it. Got 2 oxygens. Oxygen is group 6, so there's going to be 6 valence electrons there over 2 oxygens. So that's 12 valence electrons from oxygen, 4 from carbon. It's a total of 16 valence electrons we have to assign. We're going to put carbon in the middle. And carbon's got 4 valence electrons, so we'll draw those 4 valence electrons. And then we've got oxygen. And oxygen has 6 valence electrons, 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. So at the end of the day, that central carbon has 8 electrons in its outer shell. Oxygen also has 8, and the other oxygen also has 8. But what that looks like, if we're sharing 4 electrons, right, between carbon and oxygen, we need 2 electrons for 1 bond. So that means I've got a carbon-oxygen double bond on both sides, lone pair electrons on oxygen, lone pair electrons on oxygen. So in total, we have 4 carbon-oxygen bonds. But the way the question was worded, I could see how you would want to just answer for 1 carbon oxygen. There's 2 bonds there, but in total, that's what it's really looking for, is that in total we've got 4 carbon oxygen bonds in carbon dioxide.